Due to technical difficulties, our last lesson didn't go over so well, so we'll try again today. I did want to review the quick graph method using slope-intercept form. When we're given an equation, it could already be in slope-intercept form, or we might have to rewrite it. Once it's in the y is equal to mx plus b form, we're set. We'll identify our slope and the y-intercept, so that's m and b, and we'll start by graphing the y-intercept. Once we have that point on the y-axis, we'll use the slope as a starting point. We'll use that point as a starting point, and we'll use the graph to find at least one additional point. Let's practice. We may have already seen this one in the last video. I'm going over just a few of them in case you didn't get a chance to watch it. Y is equal to mx plus b. M is my slope. So if I want to identify my slope, I'll simply look at the coefficient, which generally will be a ratio of rise over run, and that will be found in front of the x coordinate there, or the x variable. My y-intercept is the constant. The constant here is 3. As it said on the previous slide, we'll start graphing at the y-intercept 1, 2, 3. A point on the y-axis is a y-intercept. We're now going to take the point and move our line either up or down and to the right. Because this is negative, it's telling us to move down 3 and then over to the right 2. 1, 2, 3, and over 2. If we're noticing the direction as we're graphing, it's going downhill. And a slope that's downhill has a negative slope, and negative 3 over 2 matches. Let's do one or two more. Starting at -1 this time, so we'll start with our y-intercept. That's our starting point. Then we're going to use this ratio of rise over run, and once again I see I have another negative. -1 is my first point. I'll count down 1, 2, and over 1, 2, 3, 4, 5. Slope is constant. I can do that again. 1, 2, and over 1, 2, 3, 4, 5, or you can even go up 1, 2, and over 1, 2, 3, 4, 5. We'll see that it's going again in the negative direction, and there's my graph. If we need to do more, I definitely have some samples here for us to try, but I'm going to skip ahead to this one, even though we may have already seen it, or it's always good to revisit. I'm looking at this equation saying that y is equal to 4/3 x. Now 4 over 3 is my ratio. It's positive, which says it's going to go up and over to the right. My y-intercept is 0. I hope you remember that when the slope is positive, it's going to go uphill, and I also hope you remember that if the y-intercept is 0, it will start at the origin. This is a model of direct variation. Y is equal to kx. So we're at that origin. I'm going to count up 1, 2, 3, 4, and over 1, 2, 3. And there is the graph of this line. You just need 2 points, and that's what we have. Let's do one where we have to rewrite. This is an equation in standard form. Slope-intercept form says let's isolate y in terms of x. We'll divide all terms by 5, and we'll see that we get y is equal to 4/5 x minus 1. My slope here is 4/5, telling me to rise up and over to the right, and my b or y-intercept is -1. Where should we start graphing? Always from the y-intercept. Now I'll count up 1, 2, 3, 4 and over 1, 2, 3, 4, 5. And connect and arrows at both ends. So again, there'll be times when we need to rewrite it in the right form in order to do our rise over run. The last thing I talked about in our previous slide that I may not have been able to do in our live session was talking about parallel lines. Parallel lines are lines that will never intersect. They'll just go infinitely in the same direction. And we're going to notice that I have a specific relationship. The slopes of parallel lines have the same or equal slopes. So looking at this example, if I were to ask what the slope of line 1 here is, it would be 3. The same of line 2, slope is 3. It was easy because these were already in slope-intercept form. Let's graph them back both to prove. Starting at y-intercept, 1, 2, 3, 4. Let's count up 1, 2, 3, and over 1. Here's line 1. Line 2 will start at negative 1. We'll count up 3, 1, 2, 3, and over 1. And we'll see that we have our second line. Parallel lines have the same slope and they will never intersect. And when we're asked to compare, there'll be times when the lines are not in slope-intercept form. And that's the way we'll be able to identify the slope easily. Let's start by rewriting each of these equations. I'll have 2y is equal to x plus 6. Divide by 2, and I'll have y is equal to 1/2 x plus 3. Slope there is 1/2. Let's take a look at the second one. I'm going to add over the x. I'm going to have 2y is equal to x minus 2. Divide by 2. I'm going to have x is equal to 1/2 x minus 1. Last one, let's subtract x over y. 2y is equal to negative x plus 4. Divide by 2, y is equal to a negative 1/2 x plus 2. If they ask us to find if any of these lines have this relationship called parallel because they have equal or identical slopes, we're going to see that line 1 and line 2, or line A and B I should say, have the exact same slope, so these two lines are parallel. Once again, we'll go over a few more problems in class.